In this video, I'm going to walk you through finding the antiderivative of sine of natural log of 3x. This is going to be a little tricky, and we're going to need to use substitution, then integration by parts twice, and then a little trick at the end that I'm going to show you. So to start off, in order to use integration by parts, I need to have two factors. I need to have something times something so I can figure out what my u and v are. So it's not set up in a way that I can use integration by parts as of right now. So this is why we're going to use substitution first. Now, because we're going to be using integration by parts as well, I'm not going to use u for our substitution like we typically do because I don't want to get our u's mixed up. So I'm going to use s instead, s for substitution. So I'm going to let s be equal to the natural log of 3x. So that means ds is going to be 1 over 3x, and then using the chain rule times 3, and then dx. Now I can simplify this by writing ds is equal to 1 over x dx. And then to replace dx, I'm going to replace dx with dx is equal to x ds. So for right now, this is what we have. I have the integral of sine natural log of 3x, we said was s. And then dx is equal to x ds. Now, because we're trying to write this with s's instead of x's, I still need to replace that x. I can't leave it like that. So I'm going to use s equals the natural log of 3x to solve this for x. And then I can plug in for this x right here and have everything in terms of s. So I'm going to use the properties of logarithms. I'm going to put this in from logarithm form into exponential form. So I'm going to write this as e to the s is equal to 3x. Now I'm going to divide both sides by 3, so I get that x is equal to 1/3 e to the s. So now I can replace that over here. So I have sine of s. That x is going to be replaced with 1/3 e to the s. But I'm going to leave the 1/3 out front here to make things a little bit easier. All right, now we've got it set up where I can use integration by parts because I've got two factors. I got this times this. I'm going to so this is going to be integration by parts, part 1. I'm going to let u be equal to e to the s. So du is going to be e to the s ds. And I'm going to let dv be equal to sine s dx. Oh, sorry, ds. So I'm going to integrate. And I'm going to get that v is equal to negative cosine s. So now we have what our u and v values are. So we have when we do integration by parts, we have u times v minus the integral of v du. So I'm going to substitute everything in. So I have e to the s times v, which is a negative cosine s, minus the integral of v, which is minus cosine s, and then du, which is e to the s ds. Now let me simplify this a little bit. Let's see. This negative here, I'm going to pull it out in front. And then I have a double negative, so I'm going to make that a plus integral of cosine s e to the s ds. Now all of this, I forgot to put that in front. Remember from the very beginning, I had that 1/3 that I had out in front. I don't want to forget that. So this is all going to be with a 1/3 in front. All right, so let's multiply through with that 1/3. So I have negative 1/3 e to the s cosine s plus 1/3 cosine s e to the s ds. All right, now this is where we're going to have to do integration by parts the second time. Okay, we're going to let u be equal to e to the s. So du is going to be e to the s ds. We're going to let dv be equal to cosine s ds. So when I integrate, I get that v is equal to sine s. Now when I rewrite this, so I'm going to carry this down. So I have negative 1/3 e to the s cosine s plus, we have 1/3, and then inside here we're going to do integration by parts a second time. So using this here, all this information here to do integration a second time, we're going to have e to the s times sine s minus the integral of v du. So I have sine s, and then dv is going to be, du is going to be e to the s ds. Now, one thing you're going to notice here is you're going to say, what the heck? This is what we started with. It's just going to keep cycling through and keep repeating. So here's where the trick comes in. But first, let's simplify this a little bit. So I have minus 1/3 e to the s cosine s plus 1/3 e to the s sine s minus 1/3 sine s e to the s ds. All right, so this is all written out. Now, remember, this is what we started with, and we're going to have to repeat the same thing over and over again. It's going to keep like cycling through and repeating. So if we look up here where we started, I'm going to call this I for integration. That's what we started with. All right, so all of this whole thing that we just wrote out, since it's what we started with, it's equal to I. That's what we started with. But this is also equal to I because that's what we started with. So when I rewrite this using i's, which was our original integral, I'm going to have 1/3 e to the s cosine s plus 1/3 e to the s sine s minus I is equal to I. Now, since I'm running out of room, I'm going to kind of combine steps here, so bear with me. If I want to solve this for I, because that's what we're looking for, right? We're looking for what this is equivalent to. What's the antiderivative of that? So I want to solve this for I. So if I add I to both sides, here's where I'm going to combine steps because I'm running out of room. I'm going to add I to both sides, so that's going to make this 2I on this side. Now, when I when I divide both sides by 2 to solve for I, this is what I get. I get minus 1/6 e to the s cosine s plus 1/3, whoops, I forgot to divide. 1/6 e to the s sine s is equal to I. Now we're almost there. I'm going to finish over here now because of lack of room. Last step is to back substitute that s. We started with x's, so we want to end with x's for our variable. So s was the natural log of 3x. So I'm going to have minus 1/6 e to the natural log of 3x cosine s plus 1/6 e to the natural log of 3x times sine s. And all this is equal to I. I'm just running out of room here. Last step, now I'm just going to simplify this. E to the natural log of x, using properties of exponentials and logarithms, that's just going to give me 3x. And so when I take negative 1/6 times 3x, the 3 and the 6 is going to reduce to 1/2, and I'm going to be left with x over 2 cosine of s plus, and the same thing over here, if I take e to the natural log of 3x and simplify it, I'm going to get 3x, and 3x over 6 is going to be x over 2 sine of, whoops, look what I did. I put s's in there instead of what I meant to put in there. Natural log of 3x. Let me fix this one too. This should be natural log of 3x. Trying to make this clear for you since it's getting kind of jammed up. Okay, so here's my final answer. It's in terms of x. And we needed to use integration by parts twice, substitution, and then this trick here, where because it's going to keep repeating over and over again and cycle through, I use a trick where I set the original integral equal to I, and since that's what we're solving for, I add I to both sides to solve for I.